All right. Hi. We're going to continue on with Unit 1. And this is gears, pulleys, drives, and sprockets. If you noticed, I put a quiz in for Friday. It will be on mechanisms, simple machines, and gears, pulleys, and sprockets. So, gears, pulleys, and sprockets, these three powertrain elements transfer energy. Okay, they transfer energy through rotary motion. So we have the speed of rotation, they change the direction of rotation, and change the amount of torque available to do the work. So, um, these three powertrain elements transfer energy. We just went through that. So, a gear train is a mechanism used for, it is a mechanism for transmitting rotary motion and torque through interlocking teeth. So, a gear train is made when two or more gears are meshed together, right? So, when we had two gears meshed together, that's what works. So, driver gear causes motion, and motion is transferred to the driven gear. So, the driver gear causes the motion input, and the output motion is transferred to the driven gear. So, mating gears are always turn in opposite directions, right? So you have this gear going this way and this gear going the opposite way. An idler gear allows the driver, and the driven gears to rotate in the same direction. So here you have an idler gear, right? And it allows both these uh, gears to go in the same direction. Mating gears always have the same size teeth. That's the diametric pitch. Okay, the diametric pitch, very important to note. Right? Okay. So the RPM of the larger gear is always slower than the RPM of the smaller gear. Gears locked together, right? The RPM of the larger gear, which is right here, whoops, is always slower than the RPM of the smaller gear, right? So you see these smaller gears um, move quickly because, right, their revolution, their circumference is a lot smaller. Gears locked together on the same shaft will always turn in the same direction and at the same RPM. Okay, so these two are on the same shaft. That's what's going to happen. Okay, so now gear ratios. The variables that we're going to deal with are the number of teeth on the gear, the diameter, which is D, the angular velocity, which is the speed, and a torque. Okay, so um, here we have the subscripts in and out are used to distinguish between gears. So this is the input gear and this is the output gear. All right, so in order to find the gear ratio, here we see that um, here we have the number of teeth out over the number of teeth in, diameter out over diameter in, angular velocity is the only one that's different. If you only have the angular velocity, it is the input over the output gear. Okay, the torque is out over in. So there you go. And here we have 12 over 6, the number of teeth, the diameter 4 over 2, 4 over 2, the angular velocity 40 over 20, right? In over out. And then our torque, which is out over in, which is 80 foot pounds divided by 40 foot pounds, gives us a 2 to 1. Okay, and that's right there. Let's get this out of the way. Okay, so what is the gear ratio between gears A and B? So here's A, right? and then here's B. Uh, gear A is the driven gear, so that is 12 over 20, which comes out to 6 to 1. 0.6 to 1 is the gear ratio, zero point 0.6. And then if we have what is the gear ratio between gears B and C, where B is the input ratio, is the input gear, and B is the output, and we have or C is the output, and we have 5 over 12, which is 0.42 to 1. And then what is the gear ratio between gears C and D? And it is 20 over 5, which gives us 4 to 1 ratio. Now, what is the total gear train ratio for this? So all that is you just take the products of all of them. So it'd be 0.6 over 1 times 0.042 over 1 times 4 over 1 gives you 1 over 1. And if you tie A and D directly to each other, you have 20 over 20, which is 1. And then if the last gear had 40 teeth, what would be the total gear ratio? And let me move this out of the way. So here you have, it would come out to 2 to 1. Okay. So gear ratios and compound machines. Okay. So force out equals MA times FN, and the torque out is gear ratio times the torque in. And so here you have mechanical advantage times force in, and gear ratio times the torque in. So total mechanical advantage is equal to mechanical advantage 1 times mechanical advantage 2, and so on. And the same with the gear ratio. Okay, so they're applied similarly to mechanical advantage, apply to torque instead of force. Okay, so mechanical advantage is used only to calculate forces, not torque. Gear ratio is used only to calculate torque and not forces. So that's the difference there. Here's a example of a compound machine. Here are 3 mechanisms in series: wheel and axle. You have your wheel and axle, your gear train, which is down here, and oops. And so if we go with the mechanical advantage of the wheel and axle, we have distance of the effort, which is 4 inches. Okay, there's your effort arm, and the resistance distance is dr is 1.5. Right here it is, gear 1, 62th radius. The radius is 1.5. Okay, 1.5. So that gives us mechanical advantage of 2.67. So mechanism number 2 is the gear train, and we have the number of teeth on the out gear is 24, and the input gear is 60. So we have 24 over 60 gives us 0.4. And okay, and then mechanical mechanism number three, again, wheel and axle. And we have our, we're down here now. And whoops, sorry. That would be the effort distance is 0.6, the radius over the distance right here. The resistance distance is 4 because these are moving this, right? And that's why it was different from here where you had this is your effort distance and you were using the radius as your resistance distance. Now to get the compound total, so you have 2.67 times 0.15 gives you a total mechanical advantage of zero point 0.4, and your gear ratio total is 0.4. Okay, so here the two middle gears share a common axle, so they rotate at the same speed. This allows the final gear to rotate slower and produce more torque if it were connected. Okay, so here we have C and B are on the same. What is the gear ratio between gears A and B? So if A is the driver, that's the input gear, and the output gear is B. So you have output over input, and you have 40 over 10 or 4 to 1. So, and here we have what is the gear ratio between gears C and D, and your input here would be C, right? Because it's driving D. So it would be D would be 50 over C, which is 20, and you have 2.5 to 1, and then the entire gear ratio is 10. And we look at belts and pulley system, and here we're looking at diameter, diameter out over diameter in, and angular velocity in. Remember, the angular velocity is in over out, and the torque is out over in. So here we had the diameter of the input diameter is 10 RPM, revolutions per minute, and the output is 6 inches. That produces 30 revolutions per minute. I'm sorry. Yeah, the output is 30 revolutions per minute. So input. I'm sorry. Out over in. Okay. And then the angular velocity is in, which is the 30 RPM over 10 RPM. Okay. So yeah, I got a little confused there myself. Don't do that. Here we have our out over in. There's our torque for there. And then here's our torque for the end. And here's a sprocket and chain system, different from a pulley because we have sprocket and chain rather than a pulley system, right? Belts and pulley system. Here we have the sprockets, and but it's the same, right? You have N over N out over N in, D out over D in, and angular in over angular out, and torque out over torque in. And these are all in the formula sheet, which you'll be able to use. But so here you see the number of teeth that we have, 22 versus 11. And that's how that works. All right. So if we're comparing the pulleys and sprockets, um, the method of transmitting the force in the pulley system, we use a belt. In the sprockets, we use a chain. The advantages of a pulley are it's quiet, no lubrication is needed, and is inexpensive. Disadvantage, it can slip, whereas the advantage for a sprocket is no slip, greater strength, but higher cost and needs lubrication, and it's noisy. But those of you that have bikes, and I'm sure y'all do, you know that chains do come off sprockets sometimes too, and they're a pain in the neck to get back on. So, but for the most part, they are stronger and they don't slip where pulleys can uh, slip. And that is that for that. All right. So this is what we'll be doing today in class.